In this quick tutorial, we'll be discussing hydrogen bonding, and we'll be doing this by answering two questions. The first question reads, one of the compounds shown here is a liquid at room temperature. Which one and why? So we have three compounds, formaldehyde, fluoromethane, and hydrogen peroxide. Now if you find the molar mass of each of these molecules, you'll notice that the molar masses are very similar. Formaldehyde is 30.03 grams per mole, fluoromethane is 34.03, and hydrogen peroxide is 34.02. This tells us that the strengths of their dispersion forces are similar. In addition, all three compounds are polar, so they have dipole-dipole forces. Hydrogen peroxide, however, is the only compound of the three that contains hydrogen bonded directly either to fluorine, oxygen, or nitrogen, and in this case, oxygen. And whenever you have that occurrence, that means the molecules are likely forming hydrogen bonds. And when hydrogen bonds are forming, the molecules are held together more closely and tightly, and so it's likely to have the higher boiling point. But keep in mind what the question is asking. Which of these is liquid at room temperature? So because hydrogen peroxide is the only one that's actually hydrogen bonding, we can safely assume that it is the liquid. Now you're probably questioning, why isn't fluoromethane, which also has a fluorine, not exhibit hydrogen bonding? The reason why is because the hydrogen is not directly bonded to the fluorine. So fluoromethane does not have hydrogen bonding as an intermolecular force. And similarly, in formaldehyde, we have oxygen bonded to carbon, double bonded. But that doesn't occur with the hydrogens. So formaldehyde also doesn't have this hydrogen bonding occurring. Therefore, to conclude, this is most likely the liquid. In question 2, we're asked, which has the higher boiling point, HF or HCl? So this molecule right here is hydrofluoric acid, and this one is hydrochloric acid. The way you determine which one has a higher boiling point is you look at the electronegativity of the halogen gas. So we have fluorine and we have chlorine. Of the two, fluorine has a higher electronegativity. So it's going to pull the overall electrons of this molecule towards it. And what will happen is the hydrogen part of the molecule will be momentarily positive, more so than the hydrogen molecule in hydrochloric acid, because the electrons are being pulled more aggressively towards the fluorine. As a result, this is going to exhibit stronger hydrogen bonding than a cupful of HCl. And as a result, this one will have a higher boiling point than hydrochloric acid. And there you have it, two examples on how to relate hydrogen bonding to a molecule state at room temperature and its boiling point.